Lecture 9, Radical Scientific Discoveries. In the last lecture, the U.S. dropping of atomic bombs in 1945 on Japan was mentioned in passing. The atomic bomb named Little Boy was dropped on August 6, 1945 from an American B-29 bomber over the Japanese city of Hiroshima. It exploded 1,903 feet above Hiroshima, instantly killing around 70,000 people and vaporizing much of the city and its people. Since the Japanese government, headed by Emperor Hirohito, refused to surrender, the U.S. dropped yet another atomic bomb, named Fat Man, on August 9, 1945, over the Japanese city of Nagasaki. This bomb also instantly killed around 70,000 people. Finally, on August 15, 1945, Japan officially surrendered. The reason that the U.S. was able to explode this devastating bomb was due to radical scientific discoveries on both the micro level and macro level. This lecture will introduce you to some of these, beginning first with the subatomic and biological discoveries before touching upon some scientific advancements in physics. War and scientific progress. One obvious reason for scientific progress is warfare, as the historian A.J. Taylor in his book on World War I clearly asserts. I quote, "War has always been the mother of invention." End of quote. In order to have a technological advantage over their opponents, nations developed scientifically during times of war. This was particularly the case during the two world wars. During World War I, the mobile X-ray machine was invented, and efficient, effective techniques of infusing blood were created. As M. Anthony Mills and Mark P. Mills explains, quote, "World War I functioned like a vast laboratory for the implementation and testing of not only organizational and administrative techniques for medical treatment, but also for the various contagion theories of disease that have been hotly debated in the medical community during the decades preceding the war." End of quote. Also, during this war, radio communication and aircraft were greatly improved upon. In 1918, the U.S. Navy even successfully launched and landed a drone. Like the drone that we now take for granted, which may soon be used commercially, the Internet similarly has its origins during the time of the Cold War between the U.S. and the Soviet Union that followed World War II. During the Cold War, the U.S. Department of Defense, the DoD, funded scientists to invent computer-controlled tools to be used in warplanes. Then, in the 1960s and 1970s, during the Cold War, the DoD funded research into connecting military and government research computers by a decentralized network. The reason was that a web-like decentralized network would greatly reduce the risk of bombs destroying vital governmental and military information. Later, these military-backed scientific advances trickled down to benefit civilians in the form of the Internet and the World Wide Web. War does not explain why people assume that since the universe is understandable, if we invest time into carefully studying it, then we'll know its laws and be able to manipulate these laws, whether by creating computers or by directing atomic energy into a massive and destructive explosion. What is the reason for explaining this belief based on the first principle that the world is understandable? This presupposes that there is an intelligent design in the universe capable of being understood by our intelligence. One explanation for this presupposition undoubtedly is the Judeo-Christian belief, referred to in a previous lecture, which believes that since the world was created, God, who is infinitely intelligent, let me state that again. Since the world was created by God, who is infinitely intelligent, and we, by being made in God's image and likeness, also are intelligent, therefore we can understand the intelligence of His creation. Catholicism, by associating logos, meaning word and reason in Greek, with Christ, through whom the Father and the love of the Holy Spirit created the world, clearly affirms that the language of the Christ as the Word is not simply mathematical, but also moral. In Christ, therefore, objective truth, including moral truth, is deeply personal, and in this personal sense, subjective, because all objective truth is located in the subject in the person of Christ. Many practitioners of modern science, though, only identify the truth with what they can measure, Everything else, including morality or experiences of beauty and love, are merely subjective and not essentially true, since they cannot be quantified and analyzed according to the modern scientific method. The famous German theoretical physicist Werner Heisenberg, active during, before, and after World War II, is an example of a foremost scientist who only identifies truth, which he calls the objective aspects of with reality, with what modern science can measure. As quoted by Joseph Ratzinger, writing as a theologian, Heisenberg stated in 1927, I quote, "Natural science is to some extent the way we approach the objective aspect of reality. Religious faith, on the contrary, is the expression of a subjective decision, by means of which we determine for ourselves the values by which we direct ourselves in life." Heisenberg further believed that as people realize that the only truth in the world is that which can be measured by the modern scientific method, traditional morality will also very rapidly break down and things will happen that are more frightful than anything we can yet imagine. As World War II progressed, his fears proved right. Ratzinger agrees with Heisenberg that the loss of morality is due to regulating morality to the realm of subjective feelings, while recognizing truth as only discoverable by scientists. He warns, I quote, "Science becomes pathological and a threat to life when it takes leave of the moral order of human life, becomes autonomous, and no longer recognizes any standard but its own capabilities." End of quote. Since modern science is defined by the scientific method of hypothesizing, followed by empirically verifying or denying the hypothesis, it cannot as a method bear within itself an objective moral code. For example, an atheist and a believer can both, without contradicting their beliefs, follow the same method to successfully build a car. The philosophical, moral worldview of the atheist and believer comes prior to following the method and is not contained in the car building instructions. Morality is found in philosophies and religions that are open to truth that cannot be precisely measured, such as justice, goodness, and evil. These moral truths, not attainable by the scientific method that is limited to measuring quantities, are the standard that determines whether scientific inventions are being used in good or bad ways. Without such a moral standard, then, there exists no measure by which to determine whether or not to drop atomic bombs on an innocent population, such as occurred during World War II, an action strongly condemned by Pope St. John Paul II, or to systematically eliminate certain human ethnicities and cultures from the earth. In our great modern fascination and appreciation of science, may we take heed of another great Pope's words, Benedict XVI, who, in his encyclical Spe Salve, reminds us that, I quote, "It is not science that redeems man, man is redeemed by love." End of quote. This love that the Holy Father is referring to is love formed by moral and doctrinal truths provided by faith, some of which are accessible to human reason when it is open to discovering truth as a moral quality within the rationality of the universe. Significant subatomic scientists. Maria Curie. Maria Curie lived from 1867 to 1934. She was a Polish physicist and chemist. She coined the term radioactivity and used this term in reference to instability in certain atoms, in particular uranium. This explanation led later scientists to discover that atoms are made up of even smaller particles. Curie tragically died from aplastic anemia caused by radiation exposure. Ernest Rutherford, from 1871 to 1937. Ernest Rutherford was a New Zealand physicist and chemist who is considered the father of nuclear physics. He studied radioactive decay and is credited with first to split the atom in 1917. Upon so doing, he discovered a subatomic particle, the positively charged proton. Niels Bohr lived from 1885 to 1962. Niels Bohr was a Danish physicist who came up with a model of the atom called the Bohr model. According to the Bohr model, an atom has a nucleus at its center, around which orbit electrons. Bohr also discovered that when electrons drop from one level of energy to another, determined by their orbit, they release energy. Bohr's work was a further development of an earlier English chemist and physicist, John Dalton. Dalton theorized that matter is made up of little particles he called atoms that can be combined into various compounds, such as water comprised of oxygen and hydrogen. Enrico Fermi lived from 1901 to 1954. Enrico Fermi was an Italian physicist who, in 1938, shortly before World War II, proposed the possibility of splitting apart particles of an uranium's atom's nuclei into atomic fragments. This breaking apart is called fission. The opposite effect is fusion, which occurs when atomic particles are fused together. In both cases, the result is the production of energy in vast quantities. The atom bombs dropped over Hiroshima and Nagasaki were fission bombs. Werner Heisenberg lived from 1901 to 1976. He was a German theoretical physicist who is famous for his uncertainty principle. According to this principle, it is impossible to precisely know the speed and location of the tiny subatomic particle of the electron, because the scientific observer use of light, which bounces off electrons, will necessarily influence either the electron's position or its velocity. Quantum theorist. Quantum theory, whose beginning theorist is considered to be the German theoretical physicist Max Planck, developed out of the research done on subatomic particles and on electromagnetic fields. Since we have already roughly covered the history of the modern subatomic particles, I will briefly introduce you to a few scientists who studied fields. The English scientist Michael Faraday and his friend the Scotsman James Clerk Maxwell proposed the concept of an electromagnetic field in which magnetism, electricity, and light are interrelated. Quantum theory studied both wave-like structures present in electromagnetic fields and subatomic particles. According to this theory, on the subatomic level, the universe appears to be undetermined and not deterministic. This explains why some changes on the subatomic level can only be determined by guesswork based on probability, since the change only occurs with a limited amount, means quantum in Latin, of subatomic particles and not in a universal manner. This means that the universe, when studied on the level of its smallest particles and waves, is fundamentally undetermined based on probability and not determined in an absolute sense, as Isaac Newton held. Biological scientific discoveries. Thomas H. Morgan, 1866 to 1945. Thomas H. Morgan was an American evolutionary biologist and geneticist who discovered that genes carried on chromosomes instructions for how living organisms are to develop. His research was based on the Austrian Augustinian friar Gregor Mendel's research on traits in pea plants. Mendel discovered that certain traits of pea plants are passed down to subsequent pea plants. Morgan further specified how this happens. Francis Crick. Francis Crick was an English molecular biologist who, along with American James Watson, in 1953 studied the DNA molecule, the matter out of which genes are made of. In studying DNA, he learned how traits are passed from an older cell to a newly generated cell. According to Crick and Watson, DNA is structured in such a way that allows it to easily transmit its genetic code. The structure of DNA consists of two twisted connected strands, the double helix that spiral around each other. These two strands transmit their genetic code to new cells. Francis Collins. Francis Collins is an American physician and geneticist who led the Human Genome Project that worked on mapping out the human genome. He once held that religion was contrary to science and identified himself as an atheist. Eventually, he converted to Christianity and published in 2007 his book, The Language of God, where he described the genetic code as, and I quote, our own instruction book previously known only to God. Modern physics. Albert Einstein. Einstein was a German-born U.S. citizen who rejected Isaac Newton's belief that matter and space are absolute realities that can be measured exactly with reference to an immovable substance called ether. According to Einstein, ether does not exist, and space and time are not absolute realities, but rather relative realities that, when influenced by gravity and acceleration, expand and contract in the case of space, and dilate and narrow in the case of time. Georges Lemaitre. Georges Lemaitre was a Belgian priest and physicist who helped Einstein to arrive at his relativity theories. One obstacle that prevented Einstein from developing his relativity theories was that he believed the universe had existed for an infinite number of time and is neither expanding nor contracting. Father Lemaitre, with his theory of the primeval atom, later called the Big Bang, convinced Einstein during a lecture Father gave in 1933 that the universe was once contained in an extremely dense point of matter that exploded outward, causing our universe to be ever expanding. God bless.